Yeah, thank you everyone for inviting me to make this presentation. I do want to say up front that the Fall Armyworm campaign, although I'm making this presentation today, is possible because of a lot of different people. In particular, I want to acknowledge Dan McGrath and Paul Jepson from Oregon State University, who have been partners in this Fall Armyworm campaign now for over 5 years. Next slide, please. So I just wanted to put a map up here very quickly, just to give us a bit of perspective. You know, Australia and the continental United States are roughly the same size. I do want to point out two things, though, on this slide. If you'll see where the word Brisbane is, right above the B is the state of Kentucky. That's that funny state that's got a bunch of squigglies around it. And then if you look at where the W is out for Washington, D.C., right to the left, that's the major corn belt in Nebraska that I'm going to be talking a little bit about today. So Nebraska, Iowa, and Kentucky, just to point that out for everybody. Next slide, please. So fall armyworm's obviously new to Asia. It's not new to the Americas. In fact, in the U.S., in particular, North America, we've been fighting this animal since literally the birth of the nation. J. Abbott was actually sent to the United States before it was the United States from the Royal Society, and he was the first guy to actually develop pictures of the fall armyworm and describe that damage. And then Townsend Glover, who was also a British immigrant to the United States, was an employee and entomologist in the patent office. We didn't have a USDA yet. Our Department of Agriculture started in the early 1860s, was one of the first people to really put together control measures for the fall armyworm in North America. There were a series of bulletins that were published 1917, 28, 29, all the way up into the release of synthetic pesticides in 1941 by the U.S. Department of Agriculture that describe how to control the fall armyworm. So again, it's a new pest in your part of the world. It's an old pest in the Americas. Next slide, please. So a couple things I want to show you on this slide. The first is, where did the name fall armyworm come from? So if you look at the two stars, Texas and Florida, in South Florida, the fall armyworm, the maize strain, is endemic year-round. And in South Texas, the so-called rice strain, which should actually be now called the range strain, I can explain that later if people are interested, are endemic in those two regions. And then as summer comes into the North America, and corn is planted starting in April, May, late June to July, July into August, the fall armyworm will move north, and it arrives in that main corn maize belt in the fall. And so farmers started calling it the fall armyworm long ago. What's interesting about this map's actually quite old. I think it was first illustrated in the 1930s or 40s. But in those days, when you talk about monitoring, what farmers would do is send a postcard to Washington, D.C. I have fall armyworm, and then by telegraph, extension agents could be informed as to what to do. Next slide, please. Much of what I'm going to talk about today is written about in detail in the Fall Armyworm Guide for Asia. USAID paid to put this together with CIMMYT. What I can tell you is all the chapters in that manual on good agricultural practices, integrated pest management, and pesticides are taken straight out of the playbook that would be used in the Americas for control of fall armyworm, using synthetic and other types of pesticides to control this pest. So this is freely available online. You can always go look it up if you wish. So how is fall armyworm managed in North America? And there's really three things that have to be in place. First is knowledge. You know, farmers and extension people have to understand what this pest is and how it acts and its biology and all those kinds of good things. There has to be a toolbox, synthetic and biopesticides, conventional host plant resistant lines of maize. And importantly, policy is important. In my experience around the world with fall armyworm, the single biggest factor impeding quick control of this pest were government policies. I can give an example. In the Americas, as I said, we've been managing this pest for a couple hundred years now. Farmers pretty much use GM maize mostly to control this pest, but there is still a large conventional and organic maize industry in the Americas that rely on other tools. So it can be managed without GM interventions. It's not easy. The organic industry, for example, in South Florida may treat with pesticides up to 12 to 25 times a season to get effective control, but it can still be done, and it can be done economically. I'll talk about that in a second. Next slide, please. The context that we use, I'm pretty sure everybody on this call will recognize this, is the standard good agricultural practices IPM model. Except with this pest, it's even a little bit more important than it is with other pests. It's a bit harder to control. You have to have your ducks in order, as they say. This is based on cultural control methods, standard soil health, planting dates, things like that. But I also want to remind the audience, especially when I talk to policymakers, the protection goal here is maize grain. If I'm a corn farmer, I'm interested in my grain. That's what I'm interested in. Everything else is secondary to me. So the use of improved maize varieties, conventional or GM, whatever your policy allows, implementing those in a smart manner so you can serve biocontrol agents, which are important with this pest, and only using pesticides then when they're necessary and economical. Over. Next slide, please. The maize variety matters. In North America, almost all the germplasm is bred for lepidopteran resistance, including fall armyworm resistance. That's even non-GM materials bred for that purpose. But I can tell you outside the U.S., what we found is a lot of maize was not bred for fall armyworm resistance. And this is just some pictures here at the bottom from CIMMYT that has screen material in Africa. And, you know, the stuff at the bottom that they originally were using was not resistant. And they very quickly were able to identify lines that are pretty tolerant to fall armyworm. Next slide, please. The key with this pest, if you're going to control it economically, is field level scouting. Farmers have to get out into the field. They have to assess whether the insect is present, and they have to decide how to act and when to act. And this process is described in the manual, as I said earlier, is based on that using the Americas, but you have to be able to identify this pest usually before you can actually see the insect. We teach farmers to identify the pest by the damage, not the actual insect itself. This is critical because this insect is actually pretty easy to control if you catch it early. Next slide, please. This is just a figure we put together to show the relative sizes of the different 6 instars of the fall armyworm. Each box is a relative representation of the size of this pest. And within the first and second and third instar, you see there to the left, this insect is pretty easy to control. It's pretty easy to kill with even some pretty simple insecticides. BTs, neem oils, things like that will control it. The key is to actually get out and find the insect in time to control it before it moves into the world of the plant where it's protected. Next slide, please. I do want to point out that in areas where this pest is endemic, you can have multiple generations of the pest present in the field across the season. So what we did here is we just put this slide together showing the growth stages of maize. This is a 100-day maize. There's a potential in a 100-day maize growing season to have up to 4 overlapping generations of this pest. And it's important for farmers to understand how to recognize the early stages of an infestation when there's overlapping generations, and they'll look different. So for example, the seedling stage infestations look like cutworm damage. Tassel damage is usually associated with poor seed set. And then, of course, especially for organic or sweet corn growers, the reproductive stage where you get cob damage. Next slide, please. I very briefly want to go through the rationale for the next couple slides because control of fall armyworm is an economic decision. And it's based on the value of the crop, the crop's yield potential, the potential damage that the pest causes, and the cost of controlling the infestation. So this is usually showed with a figure that describes what's called the economic injury level and the economic threshold. In a nutshell, what you want to do is control a pest at a level before the density of the pest becomes economically damaging. That's the key. And almost all pests, entomologists and agronomists and economists work out what that level of infestation is. They call these action thresholds. And they say, if you go into your field and you've got this level of problem, you need to do something if you want to economically control it. Now, I'll show you a couple examples of this in the next slide. So I'm going to just show you two different scenarios here. These are data from Minnesota, Wisconsin area. So an organic row crop producer on a per acre basis normally makes something on the order of $325 income off of that acre of corn. Conventional grower gets about half that. So already when you go into the discussion with your growers, you need to know these kind of numbers because that tells you what sort of intervention costs you can incur to control this pest at an economic level. So obviously organic maize is worth a lot more. The market value is higher. So your options are actually greater than they are for somebody who's a conventional row crop grower. Next slide, please. So what I want to mention very briefly are these action thresholds. Normally, for most places in North America, an action threshold of somewhere between 15 and 25% infestation in the field is considered an economic injury level that would warrant an intervention. But it doesn't have to be like that. So in the state of Nebraska that I showed you up front, farmers in that state are willing to live with up to 75% infestations before they implement controls. And these data are worked out with their agronomists, et cetera. So at the bottom here, I show, for example, data from South Africa show that even 13% yield infestations could lead to an economic loss. And it also, as I mentioned, in much of North America, 15 to 25% is usually the economic level that, or injury level, infestation level, sorry, that where an intervention will be implemented. Next slide, please. This slide is meant to show you just one thing. If you went to the state of Nebraska and you had an infestation of fall armyworm in your field and you wanted an intervention, you would go to a website and you would pull up somewhere on the order of 25 different pesticide solutions that you could use. So for example, I just blew this up here. You got, chlorantraniliprole, for example, is a very common seed treatment that's used, might have been one of the options. Next slide, please. So just to give you kind of a sense as a practitioner how you would look at this, if I had a field in Nebraska with this level of infestation, in my mind, the calculus would be, well, I could treat this with methomyl. That's around $10 per hectare. I could have, per acre. I could have treated it with chlorantraniliprole as a seed treatment. That's around $30 per acre. If I had an organic field, again, its value is much higher. Well, okay, it's more expensive to treat. It's around $100 per acre. So the idea here is you have to understand your clientele. You have to understand what crop they're growing. You have to understand its value and then apply the mitigation choices as a function of what the return on their investment is. Next slide, please. What we developed over at USDA aid to help in this process for countries that are just now engaging with the fall armyworm campaign, so we came up with this thing called the CSAS model. What's important is what is the cost of the treatment? What is its efficacy level? Safety is obviously important. Is it even accessible? GM crops, if they're not accessible, you might as well not even discuss them. And is it scalable? So for most practitioners who are first starting in this process of fall armyworm, cost and efficacy are the two biggest ones. And in terms of research, it's two of the things that the research community needs to get their head around very quickly in terms of managing this pest effectively. Next slide, please. I want to just very briefly talk about monitoring. In my experience around the world, monitoring was way oversold. It's not necessary. It's expensive. It's expensive to maintain these traps. And then you have to ask yourself what you do with the data, because trapping data doesn't correlate real well with the farmer level experience with an infestation. So considerable resources were spent globally putting these traps out into the field. In much of the Americas, for example, in the state of Kentucky, where I'm from, they only keep 2 traps for the entire state. And mostly they use those traps just to wake farmers up if they've got the infestations that fall armyworm starting to show up in the state. They'll advise farmers to start checking their field, because a lot of farmers don't routinely check for these. So it's important to realize, to appreciate that the use of trapping is mostly a field level practitioner decision, not really a country level policy decision. Next slide. Rain's important. This pest is actually pretty easy to control. And two things that where traps are important is they kind of tell you the trends of populations. Are our populations going up or the populations going down? Weather forecasts are also important. This animal can move up to 1,500 kilometers, mostly because of weather fronts that push it. And so the weather patterns are important, as are rain forecasts. Next slide, I think, might be the last. So just in summary, if you want to manage this pest, you need to have the knowledge, what the pest does and how it acts, action thresholds. You have to have the tools kit, obviously. Policy is important for those who are engaged in policy. The easy place to start is with the CSAS model. How much does the control cost? How efficacious is it? Is it safe, accessible, and scalable? Thank you.